Hey everyone, welcome back. This is Computer Science with Java, and we are learning object-oriented programming. But I want to put a stop on that for a second. Just kind of pump the brakes on object-oriented theory. We've been working on classes, instance variables, constructors, and methods. And for just a second, I want to just simplify everything and just go to some syntax of Java. For those of you familiar with programming with Python, you're going to find that a lot of this is very similar. Just a couple extra things like parentheses and curly braces that Java just requires. But other than that, most of the same rules apply. I also want to review math rules for Java. We've talked a little bit about it already, but it fits in well here, so let's do that. We're going to work with our interactive shell. So right next to the workbench at the bottom, you may have yours closed down. There's an arrow over here to the right. You can open up this shell. I've got my font pretty big size here, so hopefully you'll be able to see it. And the interactive shell allows you to code one line at a time. It basically is just for seeing things and how they behave. I kind of feel like it was Java. It came out relatively recently. Java was, first developed in the early 90s. This came out just a couple of years ago. I kind of feel like they're trying to keep up with Python for its interactiveness that makes it so good in the classroom. But it is nice. I'm glad they did it. If you want to see a result, you have to not put a semicolon. If you want to actually, do some coding, you put semicolons. So watch as most of the time I do this, I don't put semicolons because I'm looking at seeing what's behind the scenes, what's it evaluating. All right, so the first thing I want to talk about is just Booleans. A Boolean, named after George Boole, is a value that's either true or false. It can be represented in memory with a single bit. In the computer's memories, each bit can be either high or low, which is represented by a 1 or a 0. So 1 for true, 0 for false. In Java, true and false are keywords. So you just say that word, true. It does evaluate as a Boolean of type true. Notice it is lowercase. So there are two key operators called and or. If you have an or statement, true or anything is true. So if I say true or false, that should evaluate the true. Notice that the or is two vertical lines. It is not the word or like it was in Python and some other modern languages. This is a tradition that goes back way back into the 70s of using the two pipes, that shift and the key above the enter. So if I say true or true, that is also true. So true or anything is going to be true. I could also say false or true. Okay, but remember, it's two vertical pipes for or. You can also do one vertical pipe, but that's what we call a bitwise or, which is kind of different, and I don't want to go there right now. So we're using two vertical pipes. So next, let's talk about and. For something to evaluate to true in an and, both have to be true. So if I say true and false, this is going to evaluate to false. Notice the and is two ampersands, which is shift 7 on my keyboard. False and true, that's going to be false. Obviously false and false is false. False, but if I finally do true and true, that's going to evaluate the true. Okay, so you've got I don't know if we checked this one. By the way, the only way an or can be false is if both of these things are false. There is one other operator called the exclusive or, which is also a bitwise operator, and that's where you can't have both things be true. But I don't want to go there today. We're just talking about ands and ors. But you might see that it looks like the exponent symbol. It's a caret. All right, so we can combine these things to more and more elaborate expressions. So we can say x less than 5, not x, let's say 2 less than 5, and 2 greater than 1. Well, that should evaluate to true because both of those statements are true. So you could see, you could imagine how we could use variables and do these different things, but that's how they work out. All right, I want to review integer division next because again, I kind of think of Boolean as a Boolean algebra. It's actually a course you can take, so it is very mathematical. So let's talk about division. If you divide 8 by 9 in Java, you get 0 because the integer division will always give you just the quotient. And I cannot tell you enough how many times your programs will not work right because you forgot about you were doing integer division. So if you're playing with divide and something's not working right, immediately think, whoa, integer division, could that be causing you a problem? So think about that. If you want to divide real number division, you have to put a decimal on one of them. So 8 divided by 9.0 gives me that 0.8 repeating. Don't be surprised if the last digit in a result of division is not correct. Just like with Python, doing division, it's not guaranteed to be correct in the last decimal place. There are ways to make it that way, but you have to use objects. All right, so that we've talked about that. Let's talk a little bit about just order of operations. Order of operations in Java is that we are going to do all the math we can before we start doing our logic operators like our ands or our or. But you need to know that and comes before or. That can be really important, so that if I say true and false or false, this is going to evaluate first, okay, before it tries to do this. Which it wouldn't make a difference here, but you think it could. And occasionally you have to put parentheses around things if you want to force them to happen first. So I'll tell you what, let's try this one. Let's say false, and I think I can make this interesting. False and true. So what will this evaluate to? It's going to do this first, and it's going to become false or false, which is false. That is why if I want to force it to do something else first, I can put parentheses around it. Then it should evaluate true or false as true, false or, well, yeah. Let's see here. I guess it didn't matter. I'm trying to think of one that would matter. Okay, I took a moment and I thought for a minute about what could be something that if you don't know the order of operations, you might evaluate it in your head wrong. And I think I've got one. Let's do true or true and false or false. So let's talk about the different possibilities. If we evaluate the ors first, we get true here. Then we get false here. True and false would be false. But if we do the ands first, we get false here. Then we get true or false, which is true. And then we'd have, again, one more true or false, which is true. And that is the way it is done, and before or. So even if we tried to do, let's see here, true or true would be true, true and false would be false, false or false would be false. So if we try and do it just left to right, we get the wrong answer as well. You got to do and before or. Which reminds me of something else that we need to talk about. We need to talk about the not operator. In Python, you would just, and some other modern languages, you would say just the word not. Not the case in Java. It's the traditional exclamation mark, which means not. So if I say not true, I get false. And it turns out the not comes before the and. And if we have exclusive or for X, for exclusive or, we would say naxo is the order of operations. Not and, XOR, or. So for us right now, we have not, then and, then or. That is the order they evaluate. But I want to tell you, conventionally, nobody would do something like this because you should be explicit. If you want, even though order of operations says that this should happen first, use parentheses when you're coding to make sure that what's evaluated first is obvious, okay? That is the order that it does. The parentheses don't do anything here, doesn't change the outcome, but it does make it clear because you don't want readers of your code to have to sit there and remember their computer science 2 class. Just to show you that we can use parentheses to get this to evaluate differently, I'll do that. Okay, all that. Just to kind of review those things, let's practice them in an application. So I've got a project called Simple Programs, and I've created a class called App. And whenever I ask you for just a simple application, you can just write a class that has one method called run. So we'll make our class public. Public class app for application. And I'm not even going to make a constructor. I'm just going to say public void run. So this is a method, a void method that doesn't return anything. It's just going to do some work for us to, and this could be the entryway to launch several other classes to build some objects together. But for us, we're just going to print some things to the console and see what happens. Okay, so let's make some variables. Boolean. X equals true. Boolean Y equals false. So how about this? If X system.out.println X happened. So let's compile and run it. So I make an instance of it, right click on it, and then make the run method. And there's my terminal. X happened. Okay? So what that's telling me is that it took this branch. So if X, when you have a Boolean, you don't have to ask if X is equal to something. You say if true, do that. All right. So let's try this one. Change it to Y. Now it's going to be if false. And new app. And let's run it. And I should get absolutely nothing happens. Yes, because it is. And I have my terminal clear every time I run. So yours might still say X happened. So that didn't happen. So how about this? Else. So now that's how you do an else. So when you make an, notice that we put Boolean expressions in parentheses, right? Put them in parentheses. And if we can use else, we don't have to use an else, but else will run as long as the if part was not true. All right, let's try it here. I'll run it. And it says Y did not happen. So again, I'm not hammering you on the structure so much about the syntax of it. I know I should be. Pay close attention. I am putting a space after the F in if. Unlike when we write methods. I don't want people thinking these parentheses are for a method. I put a space after it. And then we always put the statement inside curly braces. Okay? All right, let's do another if statement. This time I want to make a couple different variables. Let's make int x equals 9, int y equals 12. And I'm going to say if x equals y minus 3. Okay, so it just like in Python, if you want to see if two integers are equal, you use equals equals. So one equal sign is assignment, two equal sign is to see if they're actually equal. All right, and open and close curly brace. And I'll say system.out.println hi. And let's run it. And it says hi. All right, so I hope that makes sense. That's how you check for equality, is with the two equal signs. But we can only really do that with primitives. So they have to be numbers, or you can do it with Booleans, but you cannot do it with objects. You have to use something else with objects. So let's take a look at that. I'm going to say, let's say string, that's an object, right? And string x equals super cool. And then string y equals super cool. And I'm going to say, what I have to do is I have to call the equals method like that. So that's the way it would be. Now, that if you put x equals y, that might actually kind of work, because that happens, it works sometimes for some memory saving device that Java does that I'll get into later. But I just want to go ahead and share this with you. We'll talk a lot about the dot equals method later. But when you are comparing objects, you have to use dot equals as a method, because equals will not work. It will just compare their like memory addresses. It's not the same thing. Okay. Let's write a program that will tell you what grade you got. So we're just going to make a variable. So int grade. I'm going to say 74. Okay? So this program is going to print out a congratulations if you get an A. And we're going to go down from there. So if grade, if you get an A, it must have been greater than or equal to 90, right? And I'll say system.out.println, yay, an A. And you see I'm just printing here. Close curly brace. Else if. Now, else if means only run if the previous statement was false. And I'm going to say grade is greater than or equal to 80. System.out.println, you good, a B. That's kind of confusing. It says B, you know. It looks like it's saying AB. I'll just say AB. Yeah. I don't know. What do you think? But the important thing I want to point out is how this else if works and how I'm using it to my advantage. Let's say someone got a 95. If they got a 95, I don't want them to say yay, an A, and then say good, a B. Right? That would be bad. But I didn't have to say two things here. I could just say else if grade is greater than or equal to 80. So that else if means else if you weren't bigger than 90, because that would have been true. So if that's false and this is true, do this, but it won't do both. You could do this with just a regular if statement. Take off the else, make a new line here, and I could say if grade is less than 90 and grade is greater than or equal to 80. I can do that. And that's basically the same thing, because the else if is saying the top had to not be true. All right. Okay. Now I'll say else if your grade is greater than or equal to 70. System.out.println. Okay, you got a C. Else, I'm going to use the else, right? Else they got an F. So else means I don't care what else happened. This is what we do. Notice there's no condition. We just say system.out.println. Try again. So just, remember all these conditions have to be in parentheses. That's new. We don't use a colon after the F or anything like that. We use a curly brace. Let's compile and run it. New app 1, and run. And it says we got a C, because I typed in that value for the grade, a 74, a C, so it works. All right, one last thing about if statements. Just making sure I got all my topics that I need to cover here. The thing about if statements is you'll see this from time to time. It turns out, I mean, Java doesn't require you to have the exact same formatting. It turns out you can actually not have a curly brace. You can say if, and you'll see people just do that. And then they can even take care of those. Okay? And so this is technically okay. I'm not using the curly braces even though I said you had to, right? And this will still work. I want to show you this. And then I want you to never do it. But if you're, you might see it like on if you take an AP, the AP computer science test, if you take a UIL computer science test, they do this all the time, and I don't know why nobody in the real world would do it. Look at how difficult that is to read. Like you don't know anything, and it gets even worse. Watch this. If I say system.out.println congrats, you think, okay, well, in this case, I want to say, yeah, you got an A, or yay, you got an A, and then, is that how you spell yay? I don't think it is. I think you have to say it like that. Oh, well. Someone should have said something. Then look what I got. I get this statement. Else without an if. You're like, what are you talking about else without an if? I got an if right there. Well, no, it has to be in the same block. And you can see my little purple block here. Thank you, Blue Jay, for showing me that. It actually ends. So if you want to do it without curly braces, then you can only have one line. So so often after you make an if statement, you go back and you say, oh, I need to do two things. And then you got to add the curly braces. It's a big mess. And then this, I have no words for how horrible this is. But I have seen this, and you might see it too. And I think just some people are so proud of themselves that they can code. Like on one line, they say something like this. And I have no words. It's so awful. But it works. I mean, it's just no, we're not going to do that. We're not monsters. You will occasionally see people, by the way, put parentheses down below. You may have already seen that if you looked at things online. They might even do it for classes and methods, and that's fine. That really doesn't bother me at all. I don't do it that way. I don't recommend you do it either because it's just one. It wastes a lot of space on the page. But yeah, and you'll see sometimes people put the else if below, but most people these days just put it around the side. That's the thing about Java. Unlike Python, you had to follow Python style rules, so the whole thing wouldn't work at all. With Java, you have a lot of freedom, but with great freedom comes great responsibility. You are responsible for making your code be stylistically appropriate. Okay, so yes, format like that. Makes it easy to read. We're all going to be able to work together. And when you work together in a group, you want to be syntaxed the same as everyone else so that when you come to say, hey, what's wrong with my program? Take a look. You don't go, oh my gosh, I can't read that. It's just jarring and upsetting. So, all right, well, that's today's lesson on just a quick review of some of the math principles that we have gone over about dividing. We talked about Booleans. We talked about the not, the and, the or. And we looked at just an application of the if and else if and else branch. Next lessons, we're going to look at different looping techniques. And then we're going to go into subclasses, which is when things get really cool and we're going to start doing some really neat things. So until next time, y'all, take care.